Hello class. In this video we're going to talk a little bit more about writing equations when we're given information. And the information is going to change a little bit this time. Before we begin, I just have a little exercise that I'd like to go through with you. So what I'd like you to do is I'd like you to try to graph both of these equations on the same set of graph paper, on the same set of axes. So pause this video and I'd like you to graph both of these equations. Okay, so I'd like you to pause the video again after this sentence. What I'd like you to do is I'd like you to tell me or write down a sentence about what these lines have in common. Why do they look the way that they do? So go ahead, pause the video right now and just jot down something quickly about these two lines. What do they have in common, and why do you think they have that thing in common? Okay, so if you graph these lines, they're both in slope-intercept form. They should have been pretty easy to graph. The first one starts off at 5. You have a rise of 3 and a run of 1. We can't go that way, so we'll go the opposite direction. We'll go down 3, back 1, down 3, back 1, down 3, back 1. We'll just continue it off to the edge of the graph, and we'll connect those dots. So this is what your first graph should have looked like. The second graph should have started at 1. And same slope, 1, 2, 3, up 3 over 1, up 3 over 1. In the opposite direction, I'll go down 3, back 1, down 3, back 1. And if I just quickly sketch that line, what you should have noticed was that these two lines are running side by side. And another thing that you might have noticed was they had the same slope. Okay, so that is a very key point in this exercise that we're going to be learning today, in the skill that we're learning today. And that is parallel lines have the same slope. Meaning, as one line is going up a little bit and over, up and over, up and over, the other line is doing the same exact thing. They're kind of running away from each other. So this line's going up 3 over 1. So whenever this line went up 3 over 1, up 3 over 1, the bottom line was doing the same thing. It was kind of chasing it, but it's never going to quite get there because they're both doing the same exact thing. Up 3 over 1, up 3 over 1. So key point here to start the lesson, parallel lines have the same slope. Okay, now similar to the last exercise, I'd like you to take these two equations, graph them, and then jot down a couple sentences describing how these two lines interact with each other. Okay, so hopefully what you did when you graphed it is you started off the first line at 2, the y-intercept. You went up 1 over 2, up 1 over 2, and the opposite direction, down 1, back 2, and if we just go ahead and sketch that graph here, that's our first line. The second line starts off at -3, and it goes down 2 over 1, down 2 over 1. The opposite direction will go up 2, back 1. And just a quick sketch here. And what you should have known, or what you should have noticed about these two equations, is that they cross at a special manner. If you look at them, kind of tilt your paper to the side, they form that perfect T. And a lot of you have learned what that's called. That's called perpendicular. So when two lines cross at a 90-degree angle, they form a perpendicular angle. So I want you to look at the slopes this time. They're not the same when we had parallel lines. Look at those numbers and see how they're different from each other. So they both have a 2 in them. All right. One of them is positive. One of them is negative. That's very important for perpendicular lines. For two lines to cross at a perpendicular angle, one of them must be going up and one of them must be going down. Okay, so they have to have different signs to be perpendicular. The other thing that makes lines perpendicular is the way that they're expressed. So if you look at 1 over 2, okay, that fraction is the same as the slope in the bottom equation, just flipped over, otherwise known as a reciprocal. So when you have perpendicular lines, you have what's called negative reciprocals. And so any two lines that have negative reciprocal slopes are perpendicular lines. Meaning, if any two equations have slopes where one of them is positive, one of them is negative, and one of the fractions in one slope is just flipped over, you have the reciprocal of that fraction in the other equation, then you have perpendicular lines. You won't even have to graph those lines. You will automatically know that they're perpendicular just looking at their slopes. Same thing with parallel lines. If you have two lines that have the same exact slopes, you automatically know that they're parallel. So you might be asking yourself, well, how do we use this information? Here's a common question that you'll run across in the coming tests and of course tests. Write the equation of a line parallel to y equals 3x plus 5 that runs through the point 7, 8. So if we just take a pause here and we think about the given information, what are we provided with in this equation or in this question? We know that we have a parallel line. So as soon as we hear equation of a line, we should be thinking y equals mx plus b. So we need a slope and a y-intercept. Well, line parallel to means that this line that they provided us with is going to have the same slope as our new line. So what we have in our new line is we automatically have a slope. We know that my slope for my new line is going to have to be 3. What they also tell us about this new line is that it goes through a point, 7, 8, which is an x and a y value. So the only thing missing from the situation is our y-intercept, and it becomes exactly like the same problems that we were doing a couple objectives ago. So all we have to do is plug in the information now and solve for b. So to create my equation, I need that b. So the y value is 8, the m value was 3, the x value is 7, and the b is missing. So now I can solve for my y-intercept by simplifying, picking on the lonely number, getting the b by itself. So subtract 21 from both sides. So that'll be a negative 13 equals my y-intercept. So the equation of a line that is parallel to 3x plus 5 will be y equals 3x, and it runs through the point 7, 8 minus 13. So there's our equation. Okay, I'd like you to read through this question here, and I'd like you to try to come up with the equation that is parallel to this new line, y equals 1 over 2x plus 3, that runs through the point -2, -4. If you're having trouble getting started, remember, look at what's given in this situation and figure out what you have to find. Okay, so what you should have noticed, what they gave us right off the bat was line parallel to this line. So when we're writing the equation of a line, we're thinking y equals mx plus b. All right, so parallel means same slope. So we have to just take that slope from y equals 1 over 2x plus 3 and reuse it. Okay, so if you couldn't get started before, I'd like you to pause the video again and now try to finish the problem out. Plug the point in, plug the slope in, and find the b. All right, so we take our values that they gave us. Y equals mx plus b. Plug them in, and the only thing missing is our y-intercept for our new line. So if we solve this, 1/2 times -2 is going to be -1. Get b by itself, I will add 1 to both sides. So our b is going to be -3. So we have -3 for our b value. We have 1/2 for our m value. Our equation all put together will be y equals 1/2x minus 3. So this is the equation that is parallel to our original equation, and it runs through the point -2, -4. One quick thing that you can check to make sure that it is parallel, look at the slopes. The slopes are 1/2 and 1/2. They're the same, so those lines are definitely parallel. And then one other thing that you can do to check to make sure that this point is on our new line is plug it in and see if it works. Okay, here we go. It looks like the same exact question, but I did change something. It's a small detail, but it's going to be a big thing to miss if you try to read through this problem and answer it. So if you read through this question, write the equation of the line perpendicular to y equals 1/2 x plus 3 and runs through the point -2, -4. So as soon as you hear perpendicular, the equation of a line, we should be thinking y equals mx plus b for the equation of a line. Perpendicular means negative reciprocal slopes. Negative reciprocal. And remember, what that means is whatever the old slope is, you change the sign. That's what the negative means. And then reciprocal means you take whatever fraction was there and you flip it. So the equation of a line, we're thinking y equals mx plus b. Perpendicular means we take the old slope and we're going to make it negative, so we change the sign. So it was positive 1/2, so now we're going to have negative. It was 1/2, so now our slope is going to be 2/1. So -2 is my new slope. And then again, we're given an x and a y for our new line. So if you think about this, the only thing we're missing again is our b. So with that little bit of information about negative reciprocal slopes being perpendicular and using our prior knowledge, we can now create the equation of this line. So I'd like you to take this information, plug it in, and find out what the y-intercept is to create your new line. So plug it in. -4 is our y value. Our m, our new slope, is -2. The x value that they gave us was -2. The b is missing. So we'll simplify. -2 times -2 is 4. We will have to subtract 4 from both sides. -4 minus 4 is -8. And this is our y-intercept for our new line. So altogether, y equals -2x minus 8. Okay, here we go. I'd like you to identify the given information in this problem, and I'd like you to try to create the equation. So we have a line perpendicular to y equals 3x plus 3, runs through the point 612. Remember what we just learned about perpendicular lines. Okay, so we have 3 for the slope of the old line. We know perpendicular lines have negative reciprocal slopes. So the old slope was positive. My new slope is going to have to be negative. My old slope was 3/1. My new slope has to be reciprocal to that, 1/3. So there's my new slope, perpendicular. And then the other values that we have an x and a y value. So we just plug in what's there and find our y-intercept. So y equals mx plus b. So if we solve for b, -1/3, negative times a positive will give us a negative. 1 over 3 times 6 will give us 2.